All right, number 5. In the following, we want to write expressions in terms of the given variable that represent the indicated quantities. We're going to complete parts A through G, so we got a lot to do here. A says the cost of having a plumber spend each hour at your house. If the plumbing charges $50 for coming to the house and X per hour. Okay, so we have X dollars is the cost per hour, so X money times hour plus the initial charge of 50. Okay, so our equation is going to be X dollars times H hours, XH plus the initial 50 for just coming. All right, B, the amount of money in cents in a jar containing some nickels, dimes, and quarters. Okay, so we have N plus D, nickels, dimes, plus Q for quarters. All right, and then it says there are 8 times as many nickels as dimes. 8 times as many nickels as dimes. Okay, so that's telling me dimes equals 8 times nickels. 8 times as many nickels as dimes. Actually, I think I want to rewrite this differently. The number of nickels is 8 times dimes, because there are 8 times as many nickels. So if I want to let the number of nickels and dimes be equal, and I know there are 8 times as many more, then if I want these two numbers to be equal, then I need to multiply this times 8. So kind of backwards than the way you would think. And then it says there are twice as many quarters as nickels. So twice as many quarters as nickels. So this time quarters equals 2n. Alright, so we're going to do a little substitution. So we have, we're going to put everything in terms of nickels, since we have both of these related to nickels. So nickels are going to be themselves, or actually, I guess let's just work it out. I know nickels equals 8 dimes, so I'm going to put 8D in the place of nickels, plus D in the place of D, and then I have quarters in the term of nickels, but I can also put that in terms of D as well. Alright, so quarters is equal to 2n, but we know n is equal to 8d, so I'm going to put 8d right here, 8d, so we can get everything in terms of dimes. Alright, now before I actually combine these, I need the monetary value. So the first position was nickels, and a nickel is worth 5 cents. And since it already has cents in our answer box, normally I would turn it into 0.05 as 5 cents, but it's already in terms of cents, so I'm just going to multiply this times 5. So this is the number of nickels in the first position, and I'm going to multiply this times 5. So 5, because a nickel is worth 5 cents, times 8d. Okay, a dime is worth 10 cents, so we're going to multiply 10d, and then a quarter, so let's go ahead and do 2 times 8 to give us 16. A quarter is worth 25, so we're going to say 25 cents times 2 times 8d will be 16d. Okay, so this is going to give us the amount of money in terms of dimes. 5 times 8 will give us 40d plus 10d, and 25 times 16, so there's 4 groups of 4 here, and every 4 quarters is $1, so $4, so we'll say 400 here, 400d. Now if I add up all of this, 10 and 40 will give us 50, so we get 450 in terms of dimes. Okay, so 450d. 450d. Now C wants the sum of 4 consecutive integers if the greatest integer is x. Okay, so consecutive integers like 1, 2, 3, 4. Okay, the greatest one is x, so we'll call x is this one. So what do I have to do to get to the one previous? We have to do x minus 1. Okay, and then from this we'll go back again from here, so it'll be x minus 2 and x minus 3. So if I'm adding 1 every time, these will be my 4 consecutive integers. So we want the sum. So if we add up all of these, we have 4x's, 4x, and then we get all the negatives, it'd be minus 6. So 4x minus 6 will be the sum of 4 consecutive integers with x being the largest. 4x minus 6. Alright, D wants the amount of bacteria after n minutes if the initial amount of bacteria is Q. Okay, so we're starting out with Q, and the amount of bacteria triples every 15 seconds, and then your answer should contain Q. So we want minutes, it triples every 15 seconds, so this is kind of like a geometric, so it'll be Q times R. Normally it'd be raised to the n minus 1, but we're doing in terms of minutes, so n will be our number of minutes, and then plugging everything in, we'll have Q. The rate is 3 because it's tripling every minute, every 15 seconds, and there are 4 groups. If you do a minute, it's 60 seconds, and you divide that by 15, you would get 4. So every 4 times a minute, 4n. So this will be our formula. So 3 raised to the 4th power, just for every minute, times the number of minutes. And this will give us our formula for the amount of bacteria in n minutes. So we have Q, and then parentheses 3 raised to the 4n power. Alright, the temperature T hour ago. Okay, so we're going back in time. It says T hours ago, so we're not moving forward, we're going backwards. If the present temperature is 70, and each hour it drops, so we're going back, which means T hours ago minus, and the temperature is dropping 8 degrees each hour, so 8H T. I want to use T. So minus a negative, this will give us 70 plus 8T. Okay, since we're going backwards. So we're trying to figure out how much it was maybe at 10. If it's like 1 p.m. now, so we're going back. So we actually have to add those degrees back since I said T hours ago. So 70 plus 8T. Alright, F says Powell's total earnings after 3 years. If the first year of his salary was S dollars, okay, so we have S dollars the first year, we want the total, so we have S. Second year, it was 7,000 higher, so we have the same plus 7,000. And then the third year, it was twice as much as the first year, so plus 2S. So we add up all of this. We basically get 4 S's, 1, 2, 3, 4, plus 7,000. 4S plus 7,000. That will be his total salary in 3 years. Okay, so 4S plus 7,000. Okay, G, last part. Alright, the sum of 3 consecutive even whole numbers if the greatest is x. 3 consecutive even whole numbers. Okay, so again, for example, 3 even whole numbers would be 2, 4, 6. Alright, The biggest one is x, so to get to the previous one we have to do x minus 2, and to that we'll have to do minus 2 again, so it'll be x minus 4. And if we add these up, we have 3x and minus 4 minus 2 minus 6. So 3x minus 6 will be the sum of 3 consecutive even whole numbers, greatest being x. 3x minus 6.